All right, Math 2, we're going to talk about proving triangles are congruent using the side, 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 or side, or angle, side, angle postulates. Now, I'm going to send you this PowerPoint, and you're also going to be sent a worksheet. I want you to watch this and make note of how we go about proving triangles are congruent. First, the postulates. You have side, 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 which states that if the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent. So you can see the markings, this side to this side, this side to this side, and this side to this side. The definition of included angle is, in a triangle, the angle formed by two sides is the included angle for the two sides. And the included side would be the side of a triangle that forms a side of between two given angles. So, included angle. Angle A is the angle between AB and AC, so it's the included angle for AB and AC. Angle B is in between BA and BC, so it's the included angle for BA and BC. Angle C is between CA and CB. When we talk about included sides, AB is the included side for angle A and angle B. BC is the included side for angle B and angle C. AC is the included side for angle A and angle C. Angle, side, angle. If two angles and the included side of one triangle are congruent to the two angles and the included side of another triangle, then the triangles are congruent. So, if two angles and the included side and these two angles and the included side are congruent to each other, then the entire two triangles are congruent. Side, angle, side. If two sides and the included angle of one triangle are congruent to the two sides and the included angle of another triangle, then the triangles are congruent. So we have side, angle, side, side, angle, side. Here are the steps for proving triangles congruent. You take what is given. The given is just the statement at the beginning. It is not something you have to prove. It is used as the base for which you will prove that the triangles are congruent. Then you mark your reflexive sides and vertical angles. You choose your method based on what you see. You list the parts in the order of the method. You fill in the reasons why you marked the parts. So let's take a look at how we can prove two triangles are congruent. Here we have triangle ABC and triangle CDA. We are given line AB is congruent to line CD and line BC is congruent to line DA. And we're trying to prove triangle ABC is congruent to triangle CDA. So the first thing we do is mark the given. Those two sides are congruent. And those two sides are congruent. AB to DC, or AB to CD, and BC to DA. Then we mark the reflexive sides. So the sides that match up are the shared sides. Line AC is congruent to line CA. Basically what it's saying is this line is congruent to itself because shared sides are congruent, and these two triangles share that side. Now we have to choose a method. Well, what we have here is three sides, three pairs of sides that are congruent. We have this one and this one, we have this one and this one, and we have the shared side. Then we list the parts in the order of the method we're using and fill in the reasons. So AB is congruent to CD is given, BC is congruent to DA is given, AC is congruent to CA is based on the reflexive property. The reflexive property is the same thing as saying that side is congruent to itself. And so now we can say triangle ABC is congruent to triangle CDA on the basis of the side-side-side postulate. Let's try another one. Given line AB is congruent to line CB, line EB is congruent to line DB, prove that triangle ABE is congruent to triangle CBD. First, we take care of what is given. We mark EB and DB, and we mark AB and CB. So those two pairs of sides are congruent. Now we have vertical angles. Vertical angles being the angles directly across from each other in two intersecting lines. So this angle and this angle. Now we're going to choose a method. Side, angle, side, because we have side, angle, side, and side, angle, side. List the parts in the order of the method. Line AB is congruent to line CB. That's a given. Angle ABE is congruent to angle CBD based on the definition of vertical angles. Line EB is congruent to line DB. That's given. Then we finish it. Triangle ABE is congruent to triangle CBD based on the side, angle, side postulate, because now we have identified the sides, those angles, and these two sides. Now let's try another one. Angle XWY is congruent to angle ZWY. Angle XYW is congruent to angle ZYW. Prove that triangle WXY is congruent to triangle WZY. First we take what is given, mark that, then mark the reflexive sides. We have shared sides. Line WY. Then we're going to choose a method. Well, we have angle, side, angle, and angle, side, angle. So that would be ASA, angle, side, angle postulate. We will list the parts in order, and then we'll fill in the reasons. So angle XWY is congruent to angle ZWY, that's given. Line WY is congruent to line WY, that's the reflexive postulate. Again, that's shared sides. Angle XYW is congruent to angle ZYW, that's given. And now triangle WXY is congruent to triangle WZY on the basis of the angle, side, angle postulate, because we've identified the angle, the side, and the angle. And that is 3 examples of proving triangles are congruent. We start with the given information, figure out based on that what else we can find, such as shared sides. Then we list the reasons, and then we finish it with the final statement.